In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe. In the vast reaches of space exist objects and phenomena as bizarre as any science fiction writer's imagination.
There are so many extremes in space that it's really hard for a human being here on planet Earth to imagine a lot of them.
Picture a particle that can pass right through you, a missing planet lurking in our own solar system, and clouds filled with the alcohol we drink.
The universe is filled with all sorts of bizarre things, but it's often the case that the strangest phenomena end up teaching us the most about the universe.
They're outlandish, unexplainable, and unbelievably peculiar. Take a journey to the strange side of our universe. From our Milky Way galaxy to remote regions billions of light years away, space is jam-packed with really weird stuff.
It's hard to comprehend some of the concepts and things that we find in outer space because they're so profoundly different from life on our own planet.
The more we learn, the less we know. So there's a seemingly limitless supply of strange things about the universe that remain to be discovered.
The universe is filled with objects and all sorts of mysterious phenomena that we still don't fully understand. Strange as it may seem, astronomers have discovered interstellar clouds actually filled with the same kind of alcohol found in beer.
One of the strangest clouds is one that's filled with organic molecules, in particular with ethyl alcohol. Now that, of course, is the alcohol we drink. And so the idea that there could be this huge cosmic distillery is kind of a fun idea. But in fact, that's correct.
Giant molecular clouds are enormous complexes of gas and dust. Some of them are up to 1,000 times the size of our own solar system. Their dense and sizable cores allow for the formation of complex molecules that can produce a cosmic cocktail.
In this microbrewery, barley, water, and yeast are used to produce alcohol. Whereas in interstellar molecular clouds, it's dust grains that serve as the key nucleation site for simpler molecules like molecular hydrogen, water, and carbon dioxide to come together and react chemically to form more complex molecules like ethyl alcohol. When the dust grains migrate closer to the center of the molecular cloud, they start to approach the central star that's forming in its core, and this heats them up, possibly enough to evaporate some of the complex molecules like ethyl alcohol off and into interstellar space. Thank you.
Cheers.
So just like this microbrewery, the dust grains in interstellar molecular clouds serve as meeting places where lonely molecules can form more complex molecules.
The first alcohol cloud was detected in 1975. Since then, many more of these truly strange space clouds have been observed. The cloud G34.3, which resides in the constellation Aquila, is 1,000 times the diameter of our solar system.
In fact, in G34.3, there's enough ethyl alcohol to supply 300,000 pints of beer every day to every single person on planet Earth for the next 1 billion years. That'd be one heck of a party. The only downside is that it would probably give you a pretty bad headache because it's also mixed in with hydrogen cyanide, carbon monoxide, carbon dioxide, ammonia, and some fairly other not-so-nice chemicals.
They may seem like inebriated clouds drifting aimlessly in space. Yet, as unbelievable as it may sound, these clouds eventually form multiple star systems, planets, and maybe even life.
In the outer edges of the cloud, these frozen dust grains with their complex molecules still remain intact. And in fact, we know them today as comets. And it's thought that these comets may be responsible for bringing some of these more complicated molecules into the inner solar system. And in fact, they may have seeded our own planet with these molecules, which are the building blocks of things like amino acids, which we need for life.
Our sun and Earth were formed out of an interstellar cloud, much like this cloud. And if you've got the right ingredients, the right organic ingredients, you've got the right ingredients for life.
It may seem really weird that there's this giant cloud of alcohol floating through space, but one of the things that I love is how common organic molecules, alcohol being one of them, is throughout the galaxy and the universe. We find them everywhere. If you pulverize the Earth into powder, that's basically what an interstellar cloud is like. All the chemicals that make us up.
Alcohol-laden clouds may have helped to sow the seeds of life on Earth. Yet, as incredible as it may sound, life itself may actually exist in other types of truly weird clouds. Venus, the second planet from our sun, has a hot, hellish surface. Yet, strangely, its clouds, which hover at an altitude of around 30 miles, bear temperatures that may be habitable for life.
The temperatures are roughly the same as Earth's surface. The atmospheric pressure is about the same as Earth's surface. So you might say if life can exist here on Earth, perhaps it can exist in similar conditions on Venus.
If life does exist in the clouds of Venus, how did it get there in the first place?
It's thought that the atmosphere of Venus is the product of what's called a runaway greenhouse effect, where the buildup of carbon dioxide causes the temperature to rise at the surface, which, if there were any liquid oceans of water on Venus, they would have eventually boiled away and escaped into space. Then it may have migrated up to the upper, more hospitable layers of the atmosphere.
Life as we know it needs water. The clouds of Venus contain water in the form of concentrated sulfuric acid. Here on Earth, scientists have found organisms called extremophiles that thrive in similar acidic liquids, such as the hot springs in Yellowstone National Park. So some have speculated that organisms could survive in the clouds of Venus, and they may have even evolved ways of making use of available ultraviolet light, much like plants use visible light for photosynthesis.
You have a lot of chemistry going on in the clouds. You've got sulfurs and you've got hydrogen and other elements that are needed to harbor life and to sustain life. And those are abundant at those altitudes. So it's not inconceivable that life could survive or exist in the cloud layers of Venus.
One method to test whether life could exist in the clouds of Venus is to examine the clouds above Earth.
Measurements here on Earth, for example, capturing particles of cloud and examining them in the lab have shown that very small organisms and bacteria can actually survive just sort of floating through the atmosphere, being caught up on updrafts and just gusts of wind. And they can perhaps survive in the atmosphere for long periods of time. As an analogy, the same type of behavior might be occurring on Venus. So if there were life in the Venusian atmosphere, it might just be kind of flitting along for long periods of time.
NASA may one day send a mission to Venus to find out if there's life in its clouds. But right now, scientists are keenly interested to learn whether another truly peculiar planet exists in our solar system. a mysterious planet that has yet to be discovered. Planet X is a hypothetical planet that may exist beyond Neptune.
Planet X is sort of a generic designation for an unknown planet that's somewhere in the outer solar system that remains to be discovered.
Astronomers began to speculate there might be a missing planet when observing the Kuiper Belt, a repository for icy rocks beyond the orbit of Neptune. The outer edge of the Kuiper Belt is called the Kuiper Cliff, because the density of space rocks drops off steeply here. This could be caused by Neptune's gravitational pull, or perhaps by an unknown planet.
One hypothesis for the drop-off in Kuiper Belt objects that we see after about 50 or 55 astronomical units is that there's a planet lurking out there somewhere which could be sort of hurting them inside of that region.
Scientists have wondered for decades how many planets our solar system harbors. Is there really a Planet X?
Originally, Pluto, when that was discovered, was designated as Planet X. More recently, there have been discoveries of other Kuiper Belt objects, things like Eris and Sedna, for example, that have been assigned the designation Planet X. There still remains to be the discovery of a very large object in the deep solar system. So there's sort of still this idea that a Planet X, or a mysterious hidden planet, is out in the solar system somewhere.
Scientists may soon solve the mystery of the so-called Kuiper Cliff. If a Planet X really exists, these cosmic sleuths will find it.
We think that we should be able to learn whether or not there really is such a planet relatively soon with a new generation of large-scale surveys that are going to detect anything out there.
Planet X may or may not exist. But there are other planets that have been observed far off in space that are truly out of this world. Our solar system contains some pretty unusual planets, but we're not alone. Sophisticated telescopes have now identified nearly 300 planets that are located well beyond our solar system. They're known as exoplanets. The most peculiar exoplanets are pulsar planets. Unlike most that orbit a star like our sun, these planets orbit a fast-spinning neutron star called a pulsar, which emits a pulsing radio emission, much like a lighthouse. In the 1990s, scientists actually discovered a trio of pulsar planets about 900 light-years away, located in the constellation Virgo.
If I had my say, they'd probably go down as the weirdest planets in the universe. And these planets are all very close in to the pulsar. Now, that's no place for a planet to exist. Nobody expected to find planets around these things because a pulsar, or a neutron star, is the remnant of a supernova explosion. This star has ripped itself apart in one of the most violent, chaotic explosions known in the universe. So what were planets doing there? This was a real surprise.
There are 3 of these planets, and 2 of them are about 4 times the mass of the Earth, and the third planet is about twice the mass of Earth's moon. So very small planets indeed. In fact, they orbit so close to their neutron star primary that they could actually fit within the orbit of Mercury. So they're very close in.
The enduring question is how these planets survived the supernova event at all. If the same thing happened to our sun, the planets in the inner solar system would have been vaporized.
If those planets that we see were there at the time of the supernova and they survived it, they certainly would extinguish any life that might have been on those planets. There's no hope for that. Just the power and the energy and the radiation environment of the supernova would make it pretty lethal to anything.
If the three planets weren't orbiting the star at the time of the supernova explosion, then how did they get there?
Maybe these weird pulsar planets formed from the debris surrounding the supernova, the exploding star. Maybe there was a disk of material that was shot out, but it didn't quite escape, and it left a disk of debris from which planets then formed. We don't really know how these weird pulsar planets formed. They challenge all theories so far.
Pulsar planets shed startling new insight into the formation of solar systems throughout the universe.
If the pulsar planets formed after the supernova explosion, then they're important because they indicate that planet formation can happen in rather extreme, unexpected environments. Maybe you don't need something quite as orderly as the gas that formed our own planetary system. So that's really cool. But if the planets were there before the explosion and remained bound to the star, that's an interesting challenge to theory as well, because it shows that somehow planets can remain bound in some cases.
Pulsar planets are oddities, but the neutron or pulsar stars they orbit are also quite bizarre.
Neutron star material is incredibly dense. It has a very high mass per unit volume. In fact, it's as dense as an atomic nucleus. So if I had a shovel full of sand and this were actually neutron star material, it would weigh as much as Mount Whitney in the Sierra Nevada range in California. It would have as much mass as a mountain. And a bucket full of this neutron star material would weigh as much as Mount Everest, the biggest mountain on Earth. Now, I can lift a bucket of sand quite easily, but if this were actually neutron star material, there's no way I could lift Mount Everest. That shows how incredibly dense neutron star material really is.
There are two types of neutron stars. Pulsars that spin rapidly and emit beeping radio pulses, and magnetars that spin slower and emit energy from magnetism. Magnetars, which are much rarer than pulsars, have the strongest magnetic fields known in the universe.
There aren't any places on Earth where you can find magnetic fields as strong as you find them in a magnetar. But there's kind of a parallel with this Tesla coil. The Tesla coil is originally experimented with by Nikola Tesla, who was trying to figure out how to provide electricity without having to wire homes, but actually provide electricity through the air. The Tesla coil has a big voltage difference, about 500,000 volts between the ball in the middle and the cage that surrounds it. And that gap is a release of energy that when the electrons fly through the air, releases a tremendous amount of energy that you see in those sparks. A magnetar is kind of the same thing. It's a release of energy that you see in gamma rays and X-rays.
Magnetars can release gigantic bursts of energy, not in a periodic way like a pulsar, but rather sort of at random. Something happens to the crust, like a star quake. And a bunch of magnetic fields come together and release a tremendous amount of energy, which gets turned into X-rays and gamma rays.
Magnetars and pulsars are both strange stars. But scientists have discovered something even more bizarre. A star that acts like a pulsar and a magnetar. NASA's Rossi X-ray Timing Explorer has observed this unusual star, ejecting 5 colossal outbursts of energy in the form of flares, which are characteristic of magnetars. They occurred 5 times between May and July of 2005. Each flare lasted less than a second, but released energy equivalent to tens of thousands of suns.
There's been one case of a pulsar which went through several magnetar-like outbursts that require this much stronger magnetic field and some sort of a restructuring of the magnetic field that suddenly releases a lot more energy than a normal pulsar. So we have at least one case of a link or a missing link between pulsars and magnetars. A pulsar that later showed some magnetar phenomena.
The pulsar-magnetar combo star is fairly young, less than 900 years old. So astronomers think neutron stars may begin their lives as magnetars, then settle down and become pulsars.
It could be that many neutron stars that eventually become normal pulsars actually go through magnetar-like outbursts when they're very young, just a few hundred years old or 1,000 years old. That could be the critical link. We're seeing this one when it's much younger than most pulsars that we see.
Some unusual stars exist in the cosmos. But there is equally odd small stuff in space. And recently, scientists have solved the mystery surrounding one of the most elusive things in the entire universe, a ghostly particle that passes through us every second of every day. The universe lays claim to infinite numbers of abnormal planets and stars. At the same time, there are equally strange, small things in space. Human beings and most of the universe are made up of normal matter, which primarily consists of 4 fundamental particles. One is a ghost-like particle called a neutrino.
Neutrinos would be my vote for some of the weirdest normal matter in the universe. At this very moment, every second, there are 50 trillion neutrinos actually coming from the sun that are passing through my body. And there are other neutrinos from other stars coming in different directions, right through the Earth. These things, by the trillions, are pouring into me every second, but we're completely unaware of them. They don't really interact with us at all.
There's a funny little particle called a neutrino, Italian for little neutral one. It has very little mass, very small amount of matter. Almost nothing, but it has energy and it zips through space at close to the speed of light. These things are so non-interactive that if you imagine a light-year thickness of lead and you shined a beam of neutrinos toward it, half of those neutrinos would make it through that light-year thickness of lead completely unscathed.
Neutrinos are most commonly formed by nuclear reactions inside stars, including our sun. About 60 billion solar neutrinos pass through our thumbnails every second. But there are other sources that create neutrinos.
They are produced by nuclear reactors. There's some being produced by the radioactive decay of elements in the rock around us all the time. And there are others that are actually produced when cosmic rays slam into our atmosphere. and they hit the atmosphere literally with the force of a 100-mile-an-hour fastball.
Vast numbers of neutrinos were released into the universe immediately after the Big Bang, along with other particles and light. Humans are the descendants of this primordial soup. Neutrinos are unusual small objects, but there are equally out-of-the-ordinary big things. Asteroids are the rocky leftovers from the formation of the solar system. These space rocks primarily orbit within the asteroid belt between Jupiter and Mars. Among the billions that inhabit the asteroid belt, there's one asteroid that's truly eccentric.
One of the strangest asteroids is one called Toutatis, and I guess it catches our attention a lot because it's odd. It's not perfectly round. It's kind of misshapen. It sort of looks like a bowling pin, elongated, like a bulge down here and then a narrow neck and then another bulge. Some have even said it's maybe two separate objects loosely connected.
It's got a strange rotational period where it's sort of tumbling, kind of like a badly thrown football. It's not spinning along any of its primary axes. It's actually sort of spinning along all three, tumbling through space.
Toutatis also has a highly elliptical orbit, which carries it from the asteroid belt to inside the Earth's orbit.
It's an Earth-crossing asteroid, and that puts it in the danger zone as something that could potentially strike us.
In September of 2004, Toutatis got too close for comfort. The asteroid came within 1 million miles, or about 4 times the distance to our moon.
And that's really close for an asteroid, especially for one that big. And if it were to crash into Earth, it would not slow down one bit by our atmosphere. It would really smack us and be very devastating to Earth. The next near passage isn't until about the 26th century, so hundreds of years away. So we're in good shape with Toutatis, but we have to keep an eye on it.
Toutatis is an irregular asteroid, but there are much bigger and stranger cosmic bodies that roam the universe. A moon, also known as a satellite, is a celestial body that orbits a planet or a smaller object, such as a dwarf planet or asteroid. About 240 moons exist in our solar system alone. And yet, Earth's moon is the only satellite in the solar system that perfectly eclipses the sun. But one of the most curious moons belongs to a gas giant planet in our outer solar system.
Miranda, one of Uranus's moons, is really a weird moon. It's very small. It's only about 290 miles across, so it would tuck neatly in the sort of New York to Washington corridor. But it is completely, you know, a mess.
Miranda has been named the Frankenstein moon of our solar system because of its haphazard surface.
The surface has all kinds of features and canyons and flows and cracks, and it looks like it's just been through the ringer, you know, that it's been through something. Even though it's only 290 miles across, it has canyons that are 12 miles deep. You know, by comparison, the Grand Canyon is about 280 miles long and is a mile deep or thereabouts.
What makes Miranda one of the strangest moons in the solar system is that it looks as though it was assembled from the leftover bits of other moons and planets. It's got a dual nature about the surface. You've got certain regions that appear very flat, and then other locations that are very dynamic.
Miranda puzzles astronomers because they don't know exactly how it was formed. One theory suggests that billions of years ago, the tiny moon may have been involved in a cosmic impact so immense that it broke into many icy and rocky pieces. These pieces could have melded back together in a hodgepodge of light and dark patterns and shapes. But an alternative hypothesis suggests that Miranda's surface is the result of faulting, when enormous stresses build and push large rock masses beyond their limit. It's much like what has happened here on Earth.
Vasquez rocks here in Southern California, what we see is the result of two plates on Earth's surface that are sort of pushing against each other, imparting a large amount of stress. In order to relieve that stress, you're generating folding and buckling of the surface, and that gives us these dramatic spires that we see all around. A similar type of action is occurring on Miranda, where you have enormous amounts of stress on the surface that are causing buckling and folding of the Mirandan surface, generating the peaks and scarps that we see there.
Miranda is just one of millions of unexplainable objects that make up our Milky Way galaxy. Yet our galaxy isn't the strangest one in the universe. There are others that give new meaning to the word strange. Galaxies. They're celestial neighborhoods made up of planets, stars, gas, and dust. At least 100 billion of them exist in the observable universe. But many astronomers think the most bizarre galaxies are ultraluminous infrared galaxies, also known as ULIRGs. When looking at them in the infrared light, they are 100 times brighter than normal galaxies. So they are among the most luminous in the universe.
The enormous amounts of energy being put out by these ultraluminous infrared galaxies are the result of huge bursts of star formation.
In our galaxy, about one new star the size of our sun is born every year. But in ULIRGs, about 100 new stars are formed yearly.
Stars are formed out of interstellar gas, and they're surrounded by dust, and you can't really see the stars forming, but all of that energy heats up the dust, which in turn glows in infrared light. So you're seeing all of the energy of all of these generations of stars being absorbed and re-radiated in infrared from the dust in these galaxies. So it's like there's a shroud over the galaxies, but the shroud itself is glowing really, really brightly.
ULIRGs were first discovered in the early 1980s, when the infrared astronomical satellite, known as IRAS, picked up galaxies that are extremely bright at infrared wavelengths, 1 trillion times more powerful than our sun. One of the most luminous ULIRGs has been identified as F15307 plus 3252. It's located 7 billion light years away in the constellation Boötes.
The numbers in those names refer to the direction, the coordinates in the sky where you can find the object. This one is very bright, very, relatively speaking, distant, and is a very exciting find because there's just so much star formation going on in it. You want to understand, why is that the case? How did it happen? What triggered this enormous amount of star formation that we're seeing?
One hypothesis has been that these galaxies are very active because they're the product of either mergers or near misses with other galaxies. When one galaxy passes close by another or actually hits it, You can have compression of a large amount of gas, which can set off huge waves of star formation, or can very efficiently funnel gas into the central black hole, causing a lot of heat to be produced in the surrounding accretion disk. But this is still an active area of research right now as to exactly why this process happens to make these unusual galaxies.
Supermassive black holes have been detected in the centers of ultraluminous infrared galaxies. They're regions of space where gravity is so strong that nothing can escape it, not even light. But there's an even stranger breed of black holes that may also exist. Miniature black holes are hypothetical objects smaller than atomic nuclei. Unlike their stellar mass and supermassive black hole cousins, mini black holes have never been observed. But many scientists believe that they do exist.
Mini black holes are probably nothing unusual. There's probably one right here in front of my nose right now, and one here and one here. We're probably surrounded by them.
Mini black holes might be primordial leftovers from the Big Bang. The explosion could have squeezed concentrations of matter to form black holes too small to be seen with a microscope.
And the smaller the black hole, the faster it loses mass. So if you had a little tiny black hole, like the mass of a mountain, that was created shortly after the Big Bang, then right about now, 14 billion years later, it will have evaporated so much that the remaining stuff will evaporate in a colossal explosion. Just bam!
Scientists may prove mini black holes exist by manufacturing them temporarily here on Earth. In Switzerland, scientists have built the Large Hadron Collider. It's a particle accelerator, hopefully capable of slamming subatomic particles together to replicate the energies that existed less than a second after the Big Bang.
The Large Hadron Collider is going to be able to shoot particles very fast at each other. And for an instant, there will be a lot of mass in a tiny little bit of space. And it may actually succeed in popping off little mini black holes. It's an amazing idea. We're on the verge of being able to make artificial tiny black holes in the laboratory.
If the Large Hadron Collider really does produce miniature black holes, it'll also be really exciting because it'll show that miniature black holes really do exist, or can exist, and are not just a figment of the theoretical imagination.
The mini black holes that the Large Hadron Collider may produce will last an instant before disappearing. And if successful, the experiment may also reveal secrets about another puzzling phenomenon in the universe, a matter that's completely invisible. To find this phantom matter, scientists had to look no further than our own galactic neighborhood, the Milky Way. Strange as it may seem, planets, stars, moons, and galaxies make up less than 20% of all matter in the universe. The rest is made up of dark matter, a form of matter we can't see, but exists everywhere. Dark matter was first inferred in the early 1930s, but very few scientists bought the concept at the time. But in the past 2 decades, the evidence for this invisible phenomenon has become overwhelming.
As people began to map the Milky Way galaxy, they noticed that the stars at the very edge were moving so fast, they should have actually flown off the galaxy. But they're not. They're being held together by something invisible, something that's adding more attractive force to the galaxy, more gravity. But we have no idea what this could be.
It's kind of strange that a lot of the universe we can't even see. We detect dark matter because it interacts gravitationally with mass that we do see. Galaxies spin faster than they should, counting up the amount of gravity that you can see from the matter they have. And if that gravitational attraction weren't there, the hot gas would disperse. So we know there's more gravity than we can account for by the mass that we see. And that is just simply called dark matter.
One method to measure dark matter is to look at hot X-ray emitting gas and how it's contained by the gravity present in it. Another way is to look at something called gravitational lensing.
Gravitational lensing is caused when we see a very distant galaxy behind a foreground galaxy, and the light from the distant one is bent as it goes around the nearer galaxy. That's kind of an odd idea, light actually bending in a lens that's really just formed by space itself. Gravity makes that distortion in space. So we noticed there were these gravitationally distorted galaxies that we could see, and when we estimated what the mass in the center should have been to make those distortions, it was gigantic, 10 times more than the mass we saw there. So we were observing a collection of dark matter.
Dark matter may constitute most of the mass in space, but the majority of energy in the universe comes from yet another invisible phenomenon called dark energy. It's a theoretical form of energy that exists everywhere and accounts for 70% of all mass and energy in the universe.
Probably the weirdest thing, being that it's the least understood thing in the universe, is the stuff called dark energy. Dark energy, for example, doesn't really have all that much to do with dark matter. They're different things. The dark really means we just don't know what's going on.
Dark energy was first observed in 1998 when measurements of faraway exploding stars were used to determine the distances of galaxies. Those galaxies were found to be farther away than expected in a universe that's slowing down with time. The astronomers thus concluded that the universe is actually expanding more quickly with time, and dark energy may be the culprit.
The universe is filled with this repulsive dark energy. It's really weird stuff that's causing the expansion of the universe to speed up with time, to accelerate. So it's going whoosh like that, you know, faster and faster. And that was really weird when it was found. You know, it was not anticipated.
It appears, at least to us at this time, that even more of the universe is made up of dark energy, which is some substance. It's dark, it doesn't shine, we can't see it, but it acts to speed up the expansion of the universe. It's sort of an anti-gravity.
Normal matter and energy tend to slow down the rate at which things are going away from each other because normal things pull on one another gravitationally. But dark energy appears to accelerate the rate at which objects pull away from each other. One theory suggests that dark energy will accelerate the expansion of space to such an extent that the entire universe will be ripped to shreds in about 50 billion years.
If that's the case, then eventually, not only will clusters of galaxies be ripped apart from one another, and then galaxies themselves will get ripped apart as the stars zip away from one another. And then solar systems, planetary systems will get ripped apart. And then later on, even planets will get ripped apart, and humans will get ripped apart. And finally, even atoms and subatomic particles will get ripped apart.
The universe is full of odd and interesting things. But the most peculiar thing in the universe may exist in our own backyard.
By far and away, the strangest thing, in my opinion, in the universe is Earth. And I live here, and I know something about it. What a crazy place this is, a rocky planet near a star with all this green stuff that takes sunlight and turns it into food. That's strange, but, you know, to others, there's nothing particularly peculiar because it's home.
I'd say the strangest things in outer space are human beings. We're definitely unusual, and we haven't found any other beings like us yet in the universe, although that's not to say that they aren't out there. But we're pretty strange.